Earth Science, Chapter 6, Section 10, Water Pollution and Treatment, Digging Deeper, Pollution in Surface Water and Groundwater, Kinds of Pollutants. Both surface and groundwater can become polluted. Surface water generally has more varied pollutants. There are so many ways a pollutant can get into a river or lake. Therefore, the sources of pollution of surface water are also greater. Polluted groundwater may have fewer kinds of pollutants. However, there may be more of each than in a typical surface water supply. It is usually much more difficult to solve problems of groundwater pollution than surface water. Groundwater moves far more slowly than surface water. It might take many lifetimes for pollution to clear from a large aquifer by natural groundwater flow. Many kinds of substances can pollute water. Below is a list of the most common pollutants. Most of these fall into one of two categories: organic or non organic. Organic includes sewage, livestock wastes, pathogenic, which are disease causing, microorganisms. Non organic Non-organic pollutants. The subcategories of non-organic pollutants are nutrients and fertilizers, mainly nitrates and phosphates, industrial and commercial chemicals, road salts, agricultural pesticides, acidic mining wastes, waste heat, and radioactive waste. Domestic sewage. About 75% of homes in the United States have municipal sewage systems. The remaining 25% discharges their sewage into home septic systems. Some discharge their sewage directly into the ground. The human wastes in sewage are not especially harmful. However, disease causing microorganisms are common in sewage. These are a health hazard. Many illnesses, such as cholera and typhoid, are caused by contact with sewage. Such illnesses are not common in the United States. However, in some areas of the world, people are more likely to be exposed to untreated sewage. These illnesses are much more common there. Coliform bacteria are common. They live in the intestinal tracts of all warm-blooded animals. This includes humans. They are generally not harmful. However, their presence in sewage often signals that it is contaminated. In Figure 3, water testing at Lake Kakuma, the water storage reservoir above Santa Barbara, California. Nutrients from fertilizers. Plants need many inorganic chemical nutrients for good growth. The most important of these are the elements nitrogen and phosphorus. Nitrogen is the most abundant gas in Earth's atmosphere. However, it cannot be used directly by plants. Bacteria in the soil convert nitrogen gas mainly into nitrate ions. Lightning does the same thing. Nitrates are soluble forms of nitrogen. They can be used by plants. They can be used by plants. Human-made chemical fertilizers also contain soluble nitrogen, mainly ammonia. Mixing natural gas with steam and air produces ammonia. The problem with nitrogen-containing fertilizers is that they can be too much of a good thing. Excess nitrogen promotes the growth of algae in natural surface waters. When the algae die and decay, they take the oxygen needed by aquatic animals from the water. Runoff from croplands is not the only problem. Fertilizer on lawns, golf courses, and home gardens also contain soluble nitrogen. They often carry even more excess nitrogen than the croplands. Human wastes contain water-soluble nitrogen compounds. Sometimes sewage that has not been treated properly finds its way into groundwater. Nitrate levels in drinking water can become excessive. Human infants can be harmed by drinking water that has high nitrate levels. Nitrate reduces the amount of oxygen carried by red blood cells. Too much nitrate can cause blue baby syndrome. This can lead to suffocation. Plants use phosphorus in the form of phosphate ions. The most common form of phosphorus in fertilizers is ground up phosphate rock. This is a type of sedimentary rock. Deposits of a material called guano are also mined for phosphorus. Guano is the excrement of bats and seabirds. The problem with soluble phosphorus is similar to that with nitrogen. It causes algal blooms in natural waters. The phosphates in household soaps and detergents can also pollute groundwater supplies. This is a problem in many heavily populated communities that rely on groundwater. Restrictions on the phosphate content of detergents can help to reduce this problem. In Figure 4, soluble phosphorus can cause algal blooms, such as the one shown on the left. Toxic chemicals. In the past, people used less artificial chemicals and materials than today. Many of these chemicals are health hazards. Some are toxic only after long-term use. Some of the major chemical pollutants are gasoline, chemical solvents, agricultural pesticides, and herbicides. Some others are compounds of heavy metals. These include copper, zinc, lead, mercury, and cadmium. These metals are used in the industrial processes. New substances are being developed very quickly. Government and private testing laboratories cannot keep up with the rate at which these substances are being developed. As a result, thorough testing is not always done to determine the toxicity. Many of these toxic substances find their way into surface water and groundwater supplies. In part, this is from everyday use. However, in many places, toxic chemicals have been illegally dumped. They have been left on land surface or stored in decaying drums at dump sites. Cleaning up sites all around the United States is a multi-billion-dollar task. In Figure 5, there's a photograph shown here of a site for processing toxic waste. Waste heat. Most of the electricity in the United States is generated in power plants. The burning of fossil fuels produces steam to drive turbines. The turbines drive electrical generators. Enormous quantities of water are used to cool and condense the steam. The water is then recycled in the power plant. The cooling water is put into rivers, lakes, or the ocean. It is typically 5 to 10 degrees Celsius warmer than the water that it enters. This causes three major problems. Warm water cannot hold as much dissolved oxygen as cool water. Therefore, less oxygen is available for aquatic animals. The higher temperatures also tend to lead to the disappearance of some species of organisms. They are replaced by warmer water organisms. Sudden temperature changes can kill organisms outright. This is due to thermal shock. In Figure 6, diversion dam for the Pitt River Power Plant in Central California. Water hardness. As water moves through soil, sediment or bedrock, as water moves through soil, sediment or bedrock, it dissolves some of the minerals. Water hardness reflects the concentration of dissolved solids in the water. The minerals that make water hard are mainly calcium and magnesium. Groundwater tends to be harder than surface water. It has been in contact with the solid materials longer. Hard water is also more common in areas where the bedrock is limestone. Limestone consists of the calcium carbonate mineral calcite. Calcite is slightly soluble in water. Some degree of hardness in drinking water is healthy. Calcium and magnesium are essential nutrients. Hardness also lowers the concentration of dissolved lead. Figure 7 shows damaged pipes. The lead comes from the solder that is used in copper plumbing systems. These are disadvantages to hard water. It reduces soap suds. It also can leave hard, white deposits in teapots, on shower walls, and in water heaters and boilers. Water softeners can be used to reduce hardness. They replace calcium and magnesium ions with sodium ions. A problem with water that is softened is that it contains high levels of sodium. Lots of sodium in drinking water is not good for people with high blood pressure. Water treatment. Water is purified in nature. Evaporation and condensation do this. They separate the water from things that are dissolved in it. Bacteria convert dissolved organic matter into simple and harmless compounds. Sand and gravel act as filters. They take out material that makes water cloudy. Rain and groundwater is purified by bacteria. It is filtered by sediment. This results in clean drinking water. Unfortunately, the demand for water is much greater than nature's supply. Due to this, communities rely on municipal water treatment plants. No matter where a community's water comes from, it must be treated. Even where water is used carefully, pollutants can find their way in. You cannot wash clothes, take a shower, or flush a toilet without adding pollutants to the water. The goal of the water treatment is to make water safe for drinking. It also serves to prevent a bad taste, smell, or look. Treatment of wastewater from municipal sewage systems involves a series of steps. These are screening, flocculation, filtering, and disinfecting. Depending on your local water sources and treatment needs, your community's water treatment process may be slightly different than what is shown. Keep in mind that the wastewater that passes through home septic systems is not treated at all. It goes directly into the ground. It tends to add to the pollutant levels in local groundwater supplies. Figure 8 shows water is made safe for human use at a water treatment plant. Screening, flocculation, and settling. Sewage is first passed through screens. This process removes large pieces of debris and other solids. Then it flows slowly through sedimentation tanks. There, gritty mineral materials settle to the bottom. Lightweight sludge floats to the top. To aid in the settling process, alum, which is hydrated potassium aluminum sulfate, and slaked lime, which is calcium hydroxide, are sometimes added. These cause particles of sediment to coagulate. They stick together to form larger clumps called flocks. Flocks settle relatively fast. The sludge is sent to a separate container. There, the organic matter left is digested by microorganisms. Filtration. The next treatment step is called filtration. The water is passed through sand, gravel, and activated carbon, or charcoal. Filters help remove tiny particles and odors. Water can contain inorganic or non-living components. These cannot be adequately removed by filtering. In this case, a chemical exchange process can be used. It is called ion exchange. The process is effective in treating hard water. Hard water is water that does not easily produce suds in the presence of soap. Ion exchange can also be used to treat arsenic, chromium, excess fluoride, nitrates, radium, and uranium. As part of this stage, the wastewater is aerated. It is exposed to the oxygen of the atmosphere. This greatly speeds up the natural oxidation and decomposition of organic matter in the water. This occurs due to the activity of microorganisms. Disinfection. Water is disinfected before it enters the distribution system. Disinfectants kill dangerous microbes that remain. Chlorine is very effective in doing this. It also guards against biological pollution as the water moves through pipes. Ozone is a powerful disinfectant as well. However, it does not control biological pollution in pipes. At times, the disinfecting process produces byproducts. These are called disinfecting byproducts, or DBPs. They are contaminants. They form when chlorine reacts with organic matter. This matter is in treated drinking water. Long-term exposure to some DBPs may increase the risk of cancer. It can cause other bad health effects as well. The United States Environmental Protection Agency, EPA, regulates the presence of 4 DBPs, which are disinfecting byproducts, in drinking water. Scientists continue to study the issue. Levels of treatment. Primary treatment involves only settling. It may also include chlorination. After this, water is still not suitable for human use. Secondary treatment is required. This involves filtering and oxidation. This reduces the number of microorganisms. It results in wastewater with much better quality. In some places, tertiary treatment is used. This involves flocculation and disinfecting. It may also include the use of specific additives. This process removes unwanted excess compounds. For example, it removes iron, manganese, and so on. It is done along with primary and secondary treatment. Tertiary treatment produces high-quality domestic water. This water can be added to the public water supply. Figure 9 is a diagram of a water treatment plant. Treatment costs. On a per gallon basis, water is cheap. On average, water costs are slightly more than $2 per 1,000 gallons. The costs tend to be lower for large water systems. Treatment accounts for about 15% of the cost. Other costs are for equipment. These include the treatment plant and distribution system. Some costs are also for labor to operate and maintain the system. However, at a national scale, the combined spending on water and wastewater facilities adds up. In 2014, water and wastewater utilities in the United States cost $109 billion. About two-thirds of this cost covered operations and maintenance. New equipment and machinery was about one-third of the cost. Most of these costs are paid for by state and local governments. In the United States, households pay less for water and wastewater than other developed countries' gallons per day. In 2013, the average household spent $77 per month on water and sewer costs, based on consuming 7,500 gallons per month. The same households spend, on average, twice this amount on cable and cell phone services. It is important to recognize that as consumers, we fit into a very large-scale system that uses vast quantities of water and is supported by an infrastructure of supply and treatment plants.